Hi everybody, Scott Stanchfield here. Let's talk about speech functionality inside Android. Speech can go two different directions. You can generate speech from text, so in your application you set some text and you want the device to speak to you, or you can have it do recognition of what you're saying to the device and let that command the device. Now normally with that option it's going to send information to the server to interpret, so Google is going to do that on the server side. But it is possible to install some local recognition. It can be a bit of a download for it, but it's possible to do, and I'm not going to get into the details on how here. It would really extend this session. I just want to get your feet wet with the concepts inside speech. When you're doing text-to-speech, you just create a text-to-speech instance and pass it in a lambda of what to do once that instance has been created. So in this case, I said text-to-speech, passing in the activity context, set the language, and then I'm setting a listener that's going to do my work for me. This on-utterance progress listener will tell us when it's starting to speak, when it's done speaking, if there's an error, things like that. You can use that to trigger other actions. You'll see later on in our application, we're going to use it to automatically switch over to allow the user to start talking. When you're speaking using this, you call text-to-speech speak, passing in whatever text you want them to speak, and then a couple queue options, so either add or flush. Add says, add this next message to the queue to speak in case he's already saying something. If you said queue flush, it's going to immediately stop what it's currently saying and replace it with the new item here. We also pass in a little utterance ID, which will get returned when it's telling us that it's done speaking some text, so you'll know which text it was done speaking. To do the other direction, there's really two ways to do speech to text. We can use an external application that Google provides to do it for us, or we can embed it inside the application itself. The first one, this external application, is a little bit simpler to do, and you don't need as many permissions to do it. But I don't think it really gives as nice a user experience because it's really obvious you're going outside of the application, and it pops up a big dialog to say, hey, please speak now. You can use this, and we're going to see an example of it, but it's not the friendliest way to do things. You'll start it off by setting up an intent to say where to go, and that's the action recognized speech intent. And the language model either lets it interpret the user's speech as free form or if they're doing some kind of web search. And you can pass in a prompt that you want as part of the extras to that intent. This will end up starting an external activity to prompt and recognize the text. And it'll also, in later versions of Android, pop up a toast to let the user know that it's going outside of the application and returning data just for this application to use. Once you've gotten back from that external application, you're going to get the results, and those results can include some confidence scores, and the results are sorted by those confidence scores. So most of the time, you're just going to grab the first result coming back. In your manifest, you don't need to add any permissions, but you do, in later versions of Android, need to add this queries block, as the Android system is going to restrict you from talking to other applications unless you explicitly say you want to talk to them. In order to make this communication happen, you need to set up a way to communicate. And there's really two ways to do that. There's this old method called start activity for result. So instead of saying start activity, passing an intent and going someplace else, you say start activity for result, which will go to the other activity and come back to your on activity result function. They've tried to set it up so it's a little easier to do now. You can actually encapsulate the intent creation and the result processing in something called a contract. Once you have this, you can create a launcher for it. And when you launch it, passing some options in, it'll do the action, come back and parse the result. So this particular one, there isn't one that already exists. We have seen doing this for the permission requests. There's a permission contract that we've set up, and we've used that before. But there isn't one specifically for recognizing speech, so I had to create one from scratch. This one has two arguments, the data coming in and the result coming back. Now for this particular one, we don't need any data coming in, so that I'm just passing a Boolean just to have something to pass. Yeah, I need a placeholder there. I suppose I could have used text and actually passed in the prompt for that. So I could have passed in a string instead and passed the prompt. That would be one option. But I wanted to just encapsulate this all together. So the create intent part, this is the how do I get to where I need to go. I'm going to create an intent that says I'm going to recognize speech and set up a couple extras. The language model, which is free form, and the prompt. So telling the user what do you want to do. Once the user has responded to that prompt and said something, it's going to return the results back, and parse result can handle it. The data comes in this intent that's being passed in, and the result code tells you if the user said, okay, let me have some data here, or if we're canceling the request. So if the user said everything's okay and they actually did things without hitting the cancel button, we're going to get back results in this extra results part of that intent. This intent is just being used to pass data back. We'll get those results, and I'm just going to always use the first one in this case. Now for the game that we're dealing with, I lowercase the result just to make sure we don't have any case conflicts causing us problems when we're doing parsing. If the user canceled the request, we're going to call some function to handle the cancellation. Otherwise, it's some kind of error, so we're actually going to call something for the error. We're going to see this fleshed out more in the actual application that we're performing, but this is kind of a basic structure for how you might want to do this. In order to actually launch that, we're going to call register for activity result, passing in that object that we defined. So the contract we defined here, I made it an object because I don't need to have different instances of him. And so I can just pass that in saying I want to register for activity result. And then this function down here is being passed in to handle that result coming in. That register for activity result is going to create the intent, call start activity for result. Once it gets the response back, call parse result to figure out what to do with it, and then pass that result back to this lambda. So we'll do something with it. So we set this up once, and then you can call it as many times as you want by saying that variable name, in this case recognize speech via intent, dot launch, passing in the arguments. And in this case, that's a dummy argument, so you can pass a true or false, doesn't make any difference. Now, automated speech to text is a little bit trickier here. And by automated here, I mean that we're just going to automatically listen to the user whenever we're not currently speaking. Keep in mind, this can affect the battery if we're constantly listening, as well as, in a lot of cases, the user doesn't want an application to constantly listen to them. Note that the speech recognizer, what you're speaking in there, can actually recognize any type of sound output. So if the application is currently speaking, doing text-to-speech, the speech recognizer can actually recognize it. And when I first created this application, that was quite a joy to hear because it was creating this really weird feedback loop and kind of an interesting little mess there. In order to make all this work in the manifest, we first of all need to have record audio permission, because now instead of another application handling it, and the other application would have to have that permission, we're handling it internal, so we need that record audio permission. We also need to say, here's the other service we're going to talk to, this Android speech recognition service. So again, similar to the other approach, we had to specify the intent for these queries option, which other application we're talking to. To make this work, we're going to create a speech recognizer and set up a recognition listener. So what to do when we recognize information. And here's a few of the functions inside there. On ready for speech will give you an information on when the speech recognizer is ready for the user to start talking. So you might want to put up a prompt or change some graphics on the screen. On results is when we have a result coming back. On error is when something went wrong. We need a speech intent to tell us the extra information that we're going to need for the language and the language model, whether it's freeform or not. So we set up an intent in the same way as the other way. We're going to pass that to the speech recognizer when we ask it to recognize speech. Note that we need runtime permission checks here. Record audio is what's considered a dangerous permission. That means that it's something that could expose user private information, or PII, personally identifiable information. And if you're listening to somebody and they're speaking, they could say something that they don't want getting out. So we need that runtime permission check to let the user know what we're doing and have them say, yes, it's okay to record things. Once we have that permission, we can just call speech recognizer start listening, passing in that intent for those parameters. If we want to stop at any point, we just say stop listening, and then it's not listening for anything. Our little example we're going to be doing here is a simple text adventure game. These were really popular in the 80s. I used to love these, where you'd type in commands and it would change what's going on. You know, you could be running through the Great Underground Empire. You could be doing the Hitchhiker's Guide to the Galaxy. Infocom had a bunch of great text adventures. This one's just really dirt simple. I have a simple little map here, has 5 rooms. There's a key in a room, and there's a safe in a different room. So we're going to go in, get the key, come over here, unlock the safe, open the safe, get a letter from the safe, and the letter says, you win. So nice and simple. There's a simple loop that goes through for each command that we're doing. We're going to start off by executing a text-to-speech to tell the user what the actual situation currently is. Then we're going to use speech-to-text to detect their command that they want to execute. We're going to run it through a parser to figure out what that command means, change our game state, and then repeat. So nice simple little game loop there. To do that parsing, we're using Antler. And Antler is a tool that was written by a guy named Terrence Parr. I used to work for him a while back. He had a company called Majlang, and I was a Java instructor for him. I've also done some work on Antler back in version 2. I haven't really done much since then. I think I did a little in Antler 3 when he was first doing it. We're up to Antler 4 now. But at the Antler 2 point, I actually wrote a debugger for it and did some work on the inside of how we can map the grammar to the generated code so you can debug it more easily. This is the type of tool that you would use if you're writing something like a compiler. The idea is that you're going to take some kind of input in text form, have a grammar that you've written that describes rules for what that text can mean, and then run it through the parser that's generated to figure out what the user's intent is. And the way this usually works, and most parser generators do things similar to this, is you break it down into 2 phases, a lexer and a parser. The lexer is responsible for turning characters coming through into words. In compiler parlance, we call those tokens. So if we look at the stream down here at the bottom, we have a stream of characters coming in, GET space LETTER, and the lexer is going to say, oh, I'm grouping that into get, I'm going to throw the space away, and then I'm grouping this into letter. So now I have 2 tokens that I'm going to pass on to the parser. And the parser is responsible for the semantics of the parse. And this is actually figuring out meanings. And probably the easiest way, if you're not familiar with compilers, is to just think of this as we're turning characters or letters into words, and then words into sentences, and trying to figure out what that means. Now, if you end up needing something like this, I strongly recommend you take a look at Antler. It's a really nice solution for describing your problem using a grammar and then doing something about it. On to the example. Here's a little bit of the grammar from the example that we're going to be doing. It's not the complete grammar. I cut out a few so it would fit on the slide. But if we look at the bottom here, first of all, in Antler, anything that starts with an uppercase, word, letter, and white space, those are lexer rules. And these are the ones that are responsible for turning characters into words. So we look down here, white space is either a space or a tab or a form feed. And the plus with the parens around here says one or more of these. So it's going to look for a stream of spaces, tabs, and form feeds. And anytime it has any of that, it's just going to skip it. For the letters here, a letter is either lowercase a to z or uppercase a to z. So any of those guys, that's considered a letter. Now by saying fragment, that just means that letter is never returned as something that goes to the parser. We're only going to get white space and word in this case. Word is one or more letters. So this has defined our little lexer that we're going to use for our game. The parser is defined using the lowercase rules here. So in this case, I'm saying a command, and I'm passing in a game as a parameter when I run this command check, is either get followed by a word, possibly followed by from another word, or nothing else. So it could be get something or get something from something. Those are your 2 options here. And in curly braces here, we have some text. Now in this particular example, the code that we're going to run, which is in these curly braces, is written in Java. There is a new version of the parser generator for Antler that will accept Kotlin, but it's still a little immature. I couldn't get it to work, so I actually wasn't able to use it for this example. So right now I'm just keeping it in the Java code here, which is perfectly fine because the Java code that's generated can talk to the Kotlin code very nicely. So in this case, game is going to be written in Kotlin, and the Java code that we're generating, game, get from, blah, 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 is going to pass stuff in. Notice that I'm saying W1 equals word, W2 equals word. That's assigning variables to the tokens so that I can reference them over here by saying $1, $W1 text, and $W2 text. So if I have a get from, I'm going to pass in W1 and W2. If I just have a get, I'm just going to pass in W1. The look command just calls game.look, and then each of these goes, go west, go east, go north, go south, is going to call game.go, passing in a direction. So that gives you kind of an example of how things are doing. And then we assume after this, it's the end of the feed and the end of the file coming in here. So we're just doing, because we don't have any new lines handled here, it's just a single line of input that we're dealing with at a time.